My name is Sami Pasanen. I'm the technical manager for automation, electricity and hydraulics in our company, AW Energy. I'm also the site manager of the testing facility you see here. I've been responsible of constructing it, testing it, etc. We have a full-size one-on-one scale power takeoff unit, as we have in the real MegaRoller or wave roller unit. And then we have a test bench that is basically emulating the movement of the panel. So we don't have the panel here or the big mechanisms that connect the panel into the PTO. We only have the hydraulic and electric and automation systems here. Next, we can go downstairs and check the different things we see here. First, we go and see the test bench. Then we are going to see the drivetrain unit of our power takeoff module. And the last one is the power unit. We are looking at now the pump station of our test bench. So this is the one that generates the waves. It takes electrical energy from the grid and transforms it into hydraulic energy and feeds it into the large wave generator cylinder. So basically, with this system, we are able to create 2 megawatt waves. We have 2 machines here. We have the test bench and then we have the power takeoff unit. The test bench is the machine that generates the waves and imitates the movement of the panel and the mechanism. And then the power takeoff unit is the machine that captures the energy and transforms it into electricity like in the real device. This is a one-on-one scale device. This is our control panel for downstairs. So from this we can see what is happening in the test bench and in the power takeoff unit. So we can see movement of the cylinders, are the cylinders connected to the panel. Then we can see, for example, how much power we are consuming. We can see the voltages and what is happening in the grid. And we can see how much power we are producing. And then we can see how well the cooling system is performing, for example. So it's a really nice tool. Here we can see our wave generator cylinder. It's the most important part of the test bench. This long part here forms our drivetrain module, which basically captures the energy from the panel and then transforms it into hydraulic energy with the hydraulic cylinders. Now we are looking at the most important part of our power takeoff unit. It is the 6-pack cylinder, which basically captures the energy from the panel and transforms it into hydraulic energy using normal hydraulic cylinders which have a piston that move back and forth and compress the hydraulic fluid inside the cylinder. And basically the 6-pack is constructed of 6 standard cylinders and we use them as a digital force converter. So basically we can freely choose what is the counter force to the panel. Now moving on from the stage 1, which is capturing the energy, to the stage number 2, that is the energy storage. So due to the nature of the ocean waves, which are going back and forth, they have energy spikes. So we are storing the spikes into the hydraulic accumulators, and then we are taking the power out smoothly from the accumulators and use it to run electric generators. The hydraulic accumulators are used to store the energy. Basically, they have a ram and then oil on the other side and gas on the other side. When oil is flowing into the accumulators from the cylinders, the gas compresses and stores energy. Then we take the oil out from the accumulators to the hydraulic motors that are rotating an electric generator, which is then basically transforming the hydraulic energy into electric energy. and then the oil flows back to the stage 1 and is compressed again. The power takeoff unit is cooled with active cooling. We have water pumps inside the PTO that are pumping water into the, for example, into the electric generators that are water cooled, and also the frequency converters are water cooled. So we take the heat away from those components using the pumps, and then we have a passive, this kind of box cooler on the side of the PTO that passively transfers the heat into the seawater. Here you can see our frequency converters. So the electric generators we have are driven with frequency converters. The output voltage from the converters is 500 volts, and in ocean environment that is 10. The voltage level is increased to, let's say, 10 to 20 kilovolts using a subsea transformer. And these are the drives, or the frequency converters we have are designed for mobile vehicles or ships. So they are very robust and are good to be installed inside the PTO that goes underwater. After the subsea transformer, the electric energy goes into a subsea cable that exports the energy to shore, and on shore we have a substation that connects the electricity into the grid. So basically all the components that are connecting the electricity to the grid, monitoring, control things are inside the substation. In the MegaRoller project, we've done, for example, these reliability studies with VTT. All the components we have really high quality, and all the structures are calculated using 20-year lifetime. So to ensure that we meet the maintenance interval requirements, for example, that the device is taken into a harbor every 5 years, so we can otherwise maintain it at the sea. One of the really important things we've done in the MegaRoller is increasing the reliability and maintainability of the system. Many of our project partners have delivered a lot of stuff into the testing bench. For example, Heidman has delivered all the hydraulic manifolds. And then Hydrol has delivered these hydraulic accumulators. ABB has delivered the electric generators, the drives, high voltage components. Then we've done a lot of procurement work with K2 management to procure all the big steel parts for this testing bench. They are all new, and yeah, a lot of effort has been put into this, building this testing bench by all project partners basically.